Welcome again to Flight School, episode number 4. I'm David Espejo, and I will be your host today. We'll be um, going through a deep dive or more an exploration, a technical exploration on the Flyte architecture, Flyte, the open source workflow orchestrator for ML and data. So yeah, you're welcome to ask your questions. We will have a section at the end to handle questions and answers. If you can wait until that point, that will be awesome. But feel free to drop any other comment or question in the chat whenever you have it. Great. A bit about myself. If you were here in the last episode, sorry, this is kind of repeat information, but for folks who are just joining, my professional background is mostly on the infrastructure side of the things. Infrastructure here means compute since the virtualization days to infrastructure as a service, automation, and more recently, the cloud native ecosystem, Kubernetes, etc. Yeah, probably one of the things I feel most proud of is being a former Kubernetes release team member, and especially because of the human beings that make this community, the Kubernetes community, make this project a reality. You wouldn't believe how small the team is and how big are the expectations. So it's incredible. Right, I'm a proud father of 2 boys. I enjoy bike, cycling, running, and yeah, music is very important for me. I listen classical music since I was a kid, and heavy metal also, and some other genres. In general, I enjoy learning about how music is written. All right. Cool. So the agenda will cover Flyte components, and we'll cover this from the perspective of a workflow, kind of a day in the life of a workflow in Flyte. A prototypical workflow. It won't cover all the possible uh, mm, customizations and difference. For example, we won't cover dynamic workflows, sub workflows, etc. It's a simple workflow and how it traverses the entire Flyte system and how all the components play a role there. And also how the system brings some guarantees in terms of scalability and reliability, which is still important even on the AI era. Cool. So I will start off by showing appreciation to the Union team. I'm part of Union, who sponsors this episodes, this entire show, let's say, and kind of one of the main outcomes or products of Union is Union Cloud. There are 3 folks waiting. Cool. The Union Cloud is the Flyte managed service. So in here, you basically just have your data somewhere else, and that's it. You don't have to deal with Kubernetes infrastructure, anything like that. You will have Flyte as a core engine. Everything that you will see here, you will be able to use it on Union Cloud, plus some contextual observability, and also the very sought after feature of role-based access control, right? So yeah, feel free to check it out, request demo, and also use it in a sandbox environment for free, which is great. Cool. Great. All right. Yeah, welcome everyone, and feel free to mute yourself unless you need to say something. Cool. So we'll start the exploration of the components using these planes, which is pretty much used for many systems out there. We'll start with what's closer to you, the user plane components. So the first thing that you do is to run pipe install Flyte, right? This is the SDK, right now available for Python, Java, and Scala. And you use this to author workflows, tasks, launch plans, and many other objects, right? This is the main interface you will use to author workflows. That's Flyte. Flyte CTL, think of this like the general purpose CLI that you will use to interact with the control plane. And you can perform the CRUD operations for workflow executions. And you will use it to interact with system entities. It's kind of network aware. It's not code aware. It doesn't understand your code. You use it to interact with the system mainly in the executions. With PyFlyte, it's different. If you probably take a look at the getting started guide, or if you're already familiar with Flyte, probably you already use PyFlyte, especially at the beginning. This is the code-aware CLI because it's not only interacting with the system, but it's responsible for compiling your actual workflow and task definitions into protocol of messages using a component that we will see in a little bit. And so we will parse your code, and it will understand everything and submit this to be compiled, right? So it even includes an option where it will package everything and will submit it to execution in a single command, which is PyFlyte run. You will see it in the tutorials. They all use PyFlyte run, right? So that's what's closer to the user. Those are the user plane components. In the control plane, the main component, probably what fills the entire space in the control plane, is Flyte admin, right? And Flyte admin exposes the workflow API. It processes requests to create entities, but it's not in the execution path. Flyte admin doesn't execute workflows. It receives your request for execution and create some entities. We will see in a little bit what kind of entities. And yeah, well, it's there. It's basically custom resource definitions on Kubernetes. Right now, the platform for Flyte, or the main backend, is Kubernetes. So Flyte admin will ask the Kubernetes API to create a CRD. What kind of CRD for what type of Flyte object? We will see this in a little bit. The other component in the control plane is the scheduler. This is pretty cool in my opinion, and we'll explore it in a little bit. It basically implements one of the core objects in Flyte, which is the launch plan. The launch plan is basically a definition of the inputs for a set of workflows, and also includes a definition, if you need, of a schedule, especially for batch workflows or workloads that need some kind of cadence and repeated executions. You can include the scheduling config inside a launch plan, right? And the native scheduler plays a major role in scalability, and we will see this in a bit. And the other component that sits in the control plane is data catalog. Data catalog, in my opinion, it's becoming one of my favorites. Probably it will change in the future. Hint, take a look at the artifacts RFC that it's out there in the repo. It's right now in draft state. That probably will transform how this role is completed by Flyte. But right now, even without that, data catalog is very interesting, in my opinion. It basically implements a special form of caching, which is memoization. If you're in the ML space, you know what is this, but it will basically help the data plane to store not only the outputs of a specific task, but a hash of the inputs. So every time there's a new execution request with the same inputs, it will be a catch hit basically, and the system will remember the outputs without having to execute the workflow again. It creates tags, and you will be able to retrieve specific executions, having something which is very important, and it's interesting to see it missing many times in ML, which is reproducibility. Having the chance to go back to specific execution and being able to reproduce the same outputs, and also the traceability or provenance. In our context, the provenance terms is used, being able to track, okay, what combination of inputs produce this output, which is very important. It's table stakes in software engineering. It's not on ML. And this is by default in Flyte. It's another thing that I love. If you just need to, in your code, to say catching true, to enable catching, and data catalog will do the rest, which is awesome. Okay, we'll explore all of this in more detail in this session. And finally, in the data plane, it's the Flyte propeller component. This is basically a Kubernetes controller that follows the operator pattern. Again, this is not a Kubernetes session and you don't need to understand this, but basically the operator pattern is a control loop. Again, I'm using a term from electrical engineering, but basically a thermostat, right? If you know how that thermostat works, that's exactly the operator pattern. In this case, Flyte propeller will watch for new CRDs and will understand what the user wants to do, and will kind of reconcile all this logic in the data plane. We will explore this in a little bit, right? And also, interestingly, it can be a scale out using sharding. That's for special cases when probably even before hitting scale limits in Flyte propeller, you will find scale limits on Kubernetes itself, on the Kubernetes API, and on the clusters themselves. But even so, Flyte propeller can be scaled out if you need. And finally, the plugins and the multiple integrations. The logos here are just an excerpt of the multiple integrations available right now. There's a new mechanism right now, which is the Flyte agents, to be able to write and test locally plugins, kind of making it much easier to write plugins for Flyte. Some of them are native, meaning that Flyte itself can handle the logic. Some of them rely on external services like integration with SageMaker or Databricks or others, right? So these two components sit in the data plane. If you just need to invoke a plugin or request a plugin in your code, for example, if you need to do parallel processing using Ray, you will just invoke this in the code, and in this case, Flyte propeller will call out the external system that is needed and complete the execution. Cool. Yeah, no problem. So we'll now explore a day in the life of a simple workflow, right? And we'll see how all of these elements play a role here. This is the most expensive slide that I've done in a while in terms of time. So I hope it's clear for some of you out there. If not, please let me know. Happy to improve stuff. It needs some improvement. So everything starts with you, the user, and you install FlyteKit again, and you use it to define tasks and workflows. If you're not familiar, task in Flyte is the fundamental unit of execution here. You can even run a task without a workflow. I don't know if you knew that, but I learned this recently. I've been engaged with Flyte for the past 8 months, not a lot of time, but I just learned recently that you don't even need a workflow to run a task. So really the fundamental unit of execution here is the task. And the task is each one of these granular steps in your ML pipeline. And you can write this on Python or any other language. We will see how it works in a bit. Right, so you ended up authoring your workflow. Everything is great. So you will use either PyFlyte to, again, take this code, compile it, and ship it to the control plane for execution, or you will use Flyte-CTL. This is for the special case where you have a custom image. For example, you need to have not a default Docker image, but you have a custom image and you made some changes to it. You will need to do a two-step process to submit a workflow for execution. You will use Flyte-CTL for that. But in any case, the next step, what happens behind the curtains is a packaging process. Packaging is basically submitting this to be compiled. And the component here, the first component that it touches is Flyte IDL. This is interesting because this is part of the control plane, but you won't see it in a deployment. If you install Flyte today, you won't find Flyte IDL anywhere, right? This is the interface definition language. Flyte IDL is where the definition for the core API lives, including the backend gRPC API, and it's where the compilation happens. What's the output of this? The output here will be a set of protobuf messages. The definition of these messages are part of Flyte IDL. And this protobuf will include your execution plans, the input and output types. That, remember that in Flyte, tasks are strongly typed, and Flyte is able to catch mismatches on types between outputs and inputs in task at compile time, helping you write code that is more production grade. And all of this lives in protobuf. It's saved in protobuf files. So if you just package your code, the end result will be that you will have protobuf files, and that's it. The next thing that needs to happen is that in parallel, the user will either use ImageSpec, which is a recent addition to Flyte. It's very interesting. I explained this like the build packs for ML. It's kind of similar. ImageSpec will basically scan your code. It will build the Docker image for you, right? It's having an image without the pains of writing a Docker file. You can use ImageSpec, or you can use a regular Docker build, but in the end, you will have an image living on a registry, right? And that's where that's what will be used in the end for execution. But we will see this in a bit, right? So great, you have an image, you have a protobuf files. Again, this is kind of the hard way, right? This is kind of the hard way, and probably the first time you use this, going through the hard way, right? Because the next thing that happens is that you will register these files, this compilation, to the control plane, in this case, Flyte admin, in all the cases, Flyte admin, right? What happens with PyFlyte run, for example, is that it does everything in a single command. When you do PyFlyte run, it does the packaging, the compilation, register, and execution all in a single command. But for different use cases, for example, if you have multiple Flyte admins, for you probably will be better to have some control in the process and use, for example, Flyte-CTL package and use these protobuf files and register this on multiple Flyte admins. For example, that's a use case. Cool. So now Flyte admin has a workflow registered, but nothing is being executed right now. Nothing is happening right now. So once you, for example, you can go to the UI and click on launch workflow. That's when the execution happened, or you can use the CLI to trigger an execution. And next thing that will happen is that Flyte admin will instruct the Kubernetes API server to create a CRD. CRD is a custom resource definition. And by custom, I mean that Kubernetes doesn't understand this. I mean, it just stores the CRD on etcd. Etcd is the key-value store where Kubernetes stores the definition for every resource under its management. But Kubernetes doesn't understand this. I mean, the definition of a workflow, Kubernetes doesn't understand this. There's an operator right there in the field, which is Flyte Propeller, that will constantly watch etcd for new CRDs. And Flyte Propeller will understand this. And this is the DAG, kind of the DAG structure, right? The workflow structure. And Flyte Propeller will reconcile that definition into the actual resources that need to execute the task. So for example, you have 3 tasks in your workflow, you will have 3 pods, right? 1 per task. If you need to consume secrets, if you need to consume IAM roles, if you're in the cloud, etc., all of that will be reconciled in the data plane by Flyte Propeller. And also at the same time, Flyte Propeller will send notifications back to Flyte admin. These notifications are guaranteed delivery, meaning that the workflow won't progress unless the notifications arrive. And Flyte admin will persist these events on the relational database. That's part of the reason Flyte needs relational database. Right now, Postgres, but hopefully soon it will be arbitrary backend databases. But right now it's mainly Postgres land, right? And that's the place where these events will be persisted. Right, so what happens once a task is executed? Once a task runs, it will generate outputs, right? So the metadata of the task will be stored by Flyte Propeller on blob storage. That's why Flyte needs blob storage. And by blob storage, I want to be very clear that it doesn't have to be Amazon S3, the product, right? It can be very well GCS, or it can be very well any other form of blob storage that is S3 compliant. What it in terms of S3, because I had a conversation recently with a user who was like, I don't want to use this managed S3 service. Well, you don't need it. You can even use Minio or any other thing that exposes an S3 API. That's what Flyte Propeller needs, right? To store task metadata. And if you enable caching, that's what invokes the data catalog. In data catalog, as we said, in summary, it will generate a hash of the inputs and alongside with the outputs in a data set, and it will store this in blob storage. That's the memoization portion of the process, giving you reproducibility right away. Okay. That's a good question. Can we use Azure storage? Yeah, you can use it. I mean, we have users out there. We don't have probably the best guides right now to help you with the process, but now with the recent addition of the FS spec backend supported by Flyte, we have users using Azure blob storage successfully. So yeah, you can use it. That my remark was specifically to avoid this confusion between S3 the product and S3 the API, but in general, yeah, you can use this. A POSIX compliant file system instead of blob storage. That's a good question. I'll ask you to either ask this on the Ask the Community Slack channel, or otherwise I can take this question and I can get back to you. In the end, I will show some ways we can keep connected after the session, Suki, and yeah, we can cover, because that's a fair question. Cool. Yeah, let me move on, and I will cover some of these awesome questions in at the end. Cool. So that's kind of the process for a simple workflow with caching enabled, and yeah, that's kind of the process so far. So we will see in some detail some of these elements. I will, yeah, just in the end, if the user, if you want to know what is the status, you can use again the CLI, or you can use Flyte console, which is the UI, and the UI will basically retrieve status from the control plane. Right. So these are all the components. The next session in the Flyte School series will be a live build. We will deploy live here a Flyte environment from scratch. So you will be able to see all these elements come to life. Great. So how this helps, how all this architecture helps with the scalability? Well, there are many strategies out there, and in past session we covered a bit the definitions of what makes a system scalable, which is basically to which extent you can apply low-cost strategies to help the system to handle more load, and a system is more scalable depending on how much you can extend the ability to perform well at a low cost. And this is great. I start with Go routines because this is a zero cost for the user, zero cost strategy that is enabled by default. That's what it means, zero cost in this context. You don't have to do anything with this. You don't have to even remember this. Probably you will forget this tomorrow, and it doesn't matter. Flyte still will use Go routines. Go routines are basically a native Golang mechanism. Flyte is written in Golang, and a Go mechanism to handle concurrency, right? And it's basically executes majority of the instructions inside the Go executable user space, let's say, without the usually expensive context switching of going to the operating system kernel. Performance benchmark showed that it's about 500x cheaper than operating system threads. That's how fast it is. And Flyte Propeller and other components in Flyte use these to handle concurrent workflow executions. So that's the first thing. Again, you don't need to do anything with this. You don't need to enable this. It's enabled by default, right? So concurrency, it's written inside Flyte. The other scalability, it's as I mentioned at the beginning, ML is not my background, but I had the chance to speak with many of you daily, ML engineers, data scientists, and I find consistently that in many cases, the scheduler in a workflow tends to be a bottleneck in terms of performance, especially when you start to grow. So the Flyte native scheduler brings some ideas to handle concurrency with a strong guarantee here is that no schedule is missed. Yeah, yesterday I was talking to one of the creators of Flyte because I had some questions even for this session. And yeah, the conclusion of the session was that Flyte was designed with correctness over performance as a core design tenet. And yeah, there are some trade-offs that were made after that decision, but correctness versus performance seems to be even more important. I mean, correctness seems to be more important even than performance for ML and data workloads. So one of the reflection or the implications of that decision is that, for example, in the scheduler, no schedule is missed. And also all this, every schedule in Flyte is versioned, like the workflow executions everything is versioned, so you can have this again, the stable state features, the stable states in software engineering. You can have it on ML and have the desired reproducibility. I wanted to animate this, but for some reason, Google Diagrams was not collaborating. So we'll have to use this thingy here, the laser pointer, the old school laser pointer. So what happens, what's the kind of the life cycle of scheduling in Flyte? Well, first thing that we need to say is that probably by default, if you don't have batch inference or this type of workloads, probably you don't need scheduling. But if you need it, it's typically defined inside a launch plan. Let me show you. Where are you, buddy? Yeah, it's here. Great. So let me show you real quick here. Here in docs, you can see that inside the code, you will define the launch plan and you will define the schedule. It accepts regular cron syntax, either for cron-based jobs or fixed rate jobs. And that's the first thing. You will define your schedule inside a launch plan and you will activate the launch plan. That's all you need to do. Flyte admin will read this and that will activate the schedule management system. And Flyte admin will ask the system to create a schedule. The next piece is that there is a special implementation built for Flyte for the open cron library for Go. We call it the Go cron wrapper. So it uses and extends this library. And it basically will read these schedules, be it fixed rate or cron based. And the next thing it will do is that it will create a Go routine per schedule. Again, Go routines are here, and you already saw how cheap they are in terms of resources, right? So yeah, it will create an independent Go routine per schedule. So you can have a massive number of schedules running concurrently. The next step will be that the executor, which is another component, the scheduler, will generate an execution ID that is partially based on the timestamp when the actual schedule was created, and it will submit this to Flyte admin. The idea of generating a timestamp is to ensure the most accurate execution of the jobs, not only when it was requested by the user, but actually when the schedule was created. And the idea is, again, correctness in this case in the scheduling. Another step that happens in parallel is that there's a component that is called the snapshotter. Again, you don't have to deal with anything of this. I'm just showing you what happens behind the scenes, right? And the snapshotter will read the timestamp from the last execution and periodically will persist a compact version of the timestamps in the Postgres database, in the relational database, right? Why is that? Well, again, what happens if the scheduler goes down for some reason, is not available, right? That will be the case when the schedule is missed, right? Well, what happens is that once is off and the scheduler goes down, but once it's back, the catch-up all subsystem will read the last timestamp from the database and we'll compare this with time.now. I mean, how many executions we missed until right now. And the next thing is that it will submit the missing schedules for execution. So no schedule is missed. That's one thing. And the other thing is that schedules are idempotent in a way, meaning that new executions won't affect existing executions. I mean, every new schedule execution is a different Go routine. In this case, it won't interfere with existing executions, right? Again, ensuring correctness and ensuring that no schedule is missed, right? Again, what do you need to do with this? Nothing. You just need to define your schedule, and that's it. The system will handle the rest, and that's what makes conceptually a system more scalable. Again, having strategies to handle concurrency that are low cost for users. Cool. Yeah, keep the questions coming in the chat. We will address all of them. And if I don't have answers, I will get back to you with answers. And yeah, finally, reliability, which is still important in ML. I covered this in the last session, how many observations in the field show that in some cases, failures in ML systems come from outside the ML system, and more typically they are distributed systems failures. And reliability matters. So the first thing is that in the data plane, there's a cloud native controller that I briefly described, which is Flyte propeller. In the left-hand side here, you can see kind of the definition. All the logic of Flyte propeller is this in summary. It's a reconciler that will watch for the desired state. What's the desired state? Your workflow definition. Yeah, it was compiled, it was transformed. Why Flyte uses protobuf for serialization, for compiling? Well, protobuf is very portable. So it means that you can write your workflows in any language. It's not only that it's containerized, what makes it language independent, but also the way Flyte serializes it makes it also language independent. You can write your workflows in Python or any other language right now. And that's your desired state. It's transforming protobuf files. It's submitted in as a CRD Kubernetes, and that's what the Flyte propeller will observe, will watch, and it will work 24/7 relentlessly to make the actual state match the desired state. If there's any deviation, if there's any mutation in the infrastructure, in the data plane, you as a user, you don't have to deal with this, right? This is a way we fulfill the promise of abstracting away the complexity of an infrastructure like Kubernetes. You don't have to deal with if a pod goes down, if a node goes down, if a service goes down, etc. This is handled by the reconciler. That again is a thermostat. If the temperature goes up, it will just kick off the fans and do what it needs to make the actual room temperature match what you declare as your desired state. That's the core design proposition or value proposition of Flyte propeller. And the right hand side, you see a kind of a more detailed diagram. It's in the docs, in the Flyte documentation of what Flyte propeller does. As you can see, yeah, it tracks CRDs stored on etcd, and it will handle a queue, workers, executors. It will recurse through the DAG. Flyte propeller understands the DAG, and this is important because not all the orchestrators are born equal. I mean, you can use a general purpose orchestrator to run ML workloads. That includes Kubernetes. But the problem with this is that many of these general purpose orchestrators will render something like this in serial task, one after the other. But in an ML pipeline, that's fine for software engineering. But in an ML pipeline, there are tasks that need to be a loop, that need to be repetitive. And the best way to represent this is the DAG. And you can bolt on this logic on a general purpose orchestrator, but it's totally different if this is the by default behavior and if the orchestrator was written for this, was designed for ML. And that's the case for Flyte. Cool. And yeah, again, Flyte Prepare will invoke the plugins if it's needed, if you declare that in the code. And again, it will report events to Flyte admin. So those are the reliability guarantees on the data plane. Even despite failures, it will arrive to your declared or to your desired state, right? Cool. Yeah, before demo, I will cover a bit of this questions. Yeah, the POSIX one, I will handle this after the call. Are both inputs and outputs of a task hashed and stored as part of caching? Inputs are hashed, yes, and they are stored with outputs as part of the caching mechanism. They are stored in blob storage. So the system, if the hash matches a combination of inputs, the system will remember the outputs and it will retrieve them from blob storage. And let me know if that answers your question. Can we use any FS spec compliant file system? I will say so. I will say yes, but to be 100% sure, again, I encourage you to join Slack if you're not there. Otherwise, with your name, I will reach out, or feel free to reach out to me, and I will get back to you with an answer. I mean, I can say this confidently because I always get back with an answer, even if it takes some time. But I know who to ask, and I will get back to you with an answer. Hope that's helpful. Otherwise, let me know. Cool. Yeah, real quick here. It's a simple execution. I will use here pipeflyte run. Remember that this command will do the packaging, the register, and it will submit this for execution. It will launch the workflow. It's a very simple workflow, and I'm using -- remote because the nice thing with Flyte is you can test locally, and you can then launch the same codes on your Flyte environment, which is, I don't know, your production environment. You just need to remove -- remote. You can use pipeflyte run and invoke your workflow, and you will be running locally in your Python environment. In this case, I'm using remote because I will trigger this on a I will trigger this on a Flyte cluster, which is running here locally on my laptop. Again, we will cover deployment and stuff. We will cover this in the next session. So here it is. It's running right now. This is Flyte console. Kind of the basic version. You can see here a login, not found, which is not particularly helpful. But you will see here, if you're using Oath for production environments, you will be connecting this either with the embedded authorization server or with external service like Okta, Keycloak, etc. And you will need to log in to Flyte, right? Okay, so you can see here the executions. This one is running. You can see that this one has 3 tasks, and I can show you right away. Sorry. To get pods, Flyte snacks. Oh, wait, not needed. You can see here that this one was started a minute ago and it's running. It's the node 0 of the DAG, and 0 means node 0, right? So it will be a pod per task. You don't need to go to Kubernetes to see this, but again, I'm showing you what happens behind the scenes. And you can see here workflows, all workflows that I register here. I'm running this one, but here I have a hello world. that I can launch here, right? Or I can launch from the CLI, as I described previously. Here are the tasks. Yeah, some information about task. And if you see, for example, here the execution of this simple task, you can see the inputs and the outputs, pretty basic. This one, the one that is running right now, already run yesterday, and yeah, training the model, it will generate outputs that are right now in my S3 bucket. This is a Minio bucket. So yeah, the inputs are also recorded here, and I'm not using caching on this task. Okay, as per how much time, which is a great question. How long the cache result is retained in blob storage? I'm sure this one can be controlled, but I will get back to you, Hema. That's a great question. And again, I just see here first names. If you register using Eventbrite, probably we can reach out to you. Otherwise, feel free to join Flyte Slack. I will show the link in the end. And so we can keep the discussion going, and I can connect you with folks who know better that portion of the system. Cool. And yeah, launch plans here. Here's the launch plan benchmark. I don't have a schedule for this, but this is kind of the whole plan that is created by default with the workflow. And the nice thing is that you can have multiple projects and multiple domains per project, right? This one is development, but you could have staging or production. So helping you follow a kind of a GitOps approach on handling domains and projects. And it has a match on Kubernetes. For example, you can see that the namespace is project-domain. If you move to production, it will be project-production. And yeah, you can see here it's still running. It's a bit slow on my system. Cool. So yeah, that's kind of the summary. So far, is there any other question out there? As you can see, I don't have all the answers, and that's fine because it's near to impossible. So but I'll make sure that you have your answers soon. Okay, see some familiar names here. Any other question? No? Okay, cool. So yeah, I will just finish by asking you to join the Flyte community in this case. The Slack instance is where the majority can trigger runs by cruns. Sorry, a question coming. We can trigger runs by cruns, but can we run a workflow where another one finishes? Yes, that's possible. There's a mechanism for that. I can forward you the docs, and but yeah, that's entirely possible on Flyte. And yeah, feel free to connect on Slack so that the conversation persists and everyone can see the link after the fact. So yes, Sari, feel free to reach out. Cool. Yeah, again, join the Slack community. Is where we spend most of our time, and also feel free also to start discussions on the Flyte repo. Start the repo, both for issues. Again, we're happy to interact. This is a fairly active community. We are proud of it, and we're happy to help. On LinkedIn, we are as Flyte. You will find many other Flytes, right? Flyte company, some other kind of consultancy job, maybe. But yeah, find the Flyte that has this logo, the or Flyte, right? And in the social network formerly known as Twitter, we are as Flyte.org. You can reach out to me directly also on LinkedIn and David Espejo, and you'll find my picture there. And I'm also on Twitter, but not very active these days, to be honest. Cool. Another question from Alex. Is it sensible to pull an external service in a workflow? I read it's currently an anti-pattern, but not sure why. Yeah. I'm not sure also why. Alex, sorry. Being completely honest. But again, we can continue this conversation on Slack. There is where there's the people who can cover better why this is an anti-partner. Because yeah, this has been a kind of a recurring conversation here and there. And yeah, feel free to reach out, Alex, sorry, or otherwise we'll reach out. Yeah, I read that we should avoid side effects within tasks and workflows. Yeah, I don't know, if, Juan, if you want to unmute and you could elaborate better. What do you mean by side effects in this context?
So I guess it's something I read in the Flyte docs themselves, that we should not read from any other data source within the execution of a task or our workflow. We should only do that between stages, between tasks inside a workflow.
Okay, thank you. That helps. Yeah, I mean, we need to dive a little deep on this. And I know that you are already in this Slack community one, which is great. And thank you for your contributions. Yeah, I'll make sure that we discuss this there as a follow-up for sure. Cool. Any other question for my backlog? Anything else? No? Awesome. Okay, I hope this was useful to some of you. How this was helpful. Since yesterday, I knew this one, and I was telling the team today we need a follow-up for this. This session won't be enough, and I know. And there will be a follow-up for the session where we can start really from first principles, from a task and above, and probably we can bring some folks to handle this really deep dive questions. But besides that, I really enjoyed this. I enjoyed your engagement, your questions. Thank you all for joining. And yeah, we'll see you in the next one. Again, feel free to reach out on Slack, on social media. We're happy to help.